Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the chapter chemical bonding. In this session we are going to say about valence bond theory, which is familiar as VBT, valence bond theory, which explains about the covalent bond formation in the modern way. So this we say as a modern concept of covalent bonding. As we know that Lewis' approach helps in the writing the structure of molecules, but it fails to explain the formation of chemical bond, isn't it? From the Lewis approach, we're able to understand how the molecular structure of a substance is, how atoms are connected to one another. We can understand that from Lewis approach, Lewis dot structures. But that Lewis concept cannot explain how a chemical bond is formed, isn't it? It does not explain the formation of chemical bond. It also does not give any reason for the difference in the bond dissociation enthalpies and bond lengths in the molecules like hydrogen and fluorine. If you observe, both are in both the cases we can observe a single bond, isn't it? In case of hydrogen molecule, there is a single bond between two hydrogen atoms. And even in case of fluorine molecule also, there is a single bond between two fluorine atoms. So according to Lewis approach, what we can say, how many bonds are there between the two atoms in these two molecules. But there is a difference in their bond enthalpies, means the energy required to break those bonds is different in case of hydrogen and fluorine. And not only that, even bond lengths are also different from hydrogen to fluorine. So why these are being different even though they are of single bonds? Both are single bonds. So this difference, why these differences are there in the properties like bond energies, bond lengths, that was not explained in the Lewis concept. Okay. So although in both the cases a single covalent bond is formed by this sharing of an electron pair between the respective atoms, isn't it? Even though in both the molecular formations of H2 and F2, a single electron pair is shared between the two atoms of those molecules, but there are certain differences in the properties. So according to Lewis dot structures, both will be represented as same, as single bond, which is formed by sharing of a pair of electrons. But there is a lot of difference in their properties. They are having different bond energies and even bond lengths also. Why they are so being different, not explained in the Lewis approach. So it also gives no idea about the shape of the polyatomic molecules. So not only about this, about the polyatomic molecules, Lewis dot structure did not explain how their shapes are being in three-dimensional way. It was not explained in the Lewis concept. Of course, in the valence shell electron pair theory, the shapes are explained. So similarly, in the valence shell electron pair repulsion theory, it gives the geometry of the simple molecules, but theoretically it does not explain them. And also it has limited applications. So which was not explained in the Lewis dot structures, that is shapes. Shapes of the molecules are explained in the valence shell electron pair repulsion theory, but it is theoretically. So, and again, it does not explain them in the theoretical way. And also it is limited, it has a limited applications. It is not applicable for all kinds of molecules. So to overcome these limitations, an important theory based on quantum mechanical principles is introduced. That is valence bond theory. Okay, this theory was proposed by Hitler and London in 1927 to explain how a covalent bond is formed. Okay, in the earlier concepts, they explained how these bonds are existing between the atoms and how the shapes are. What are the reasons for the bond formations were not explained in the earlier concepts, and even why the difference are being, even they are being single bonds or double bonds, why the differences between the different kinds of molecules are existing were not explained in the earlier concepts. So to explain about those all, to explain how a covalent bond is formed, this valence bond theory was proposed by the scientists Hitler and London in 1927. This theory was later extended by Pauling and Slater in around 1931. It is a bit advanced. So the valence bond theory is based on the knowledge of atomic orbitals, electronic configurations of elements, and the overlap criteria of atomic orbitals. So based upon these all concepts, this valence bond theory is developed. Consider two hydrogen atoms A and B approaching each other having nuclei Na and Nb and electrons present in them are Ea and Eb respectively. Okay, these two are hydrogen atoms. When these two atoms are approaching each other, suppose, so the nucleus of first hydrogen is represented as Na and the nucleus of second hydrogen is represented as Nb, and their electrons are respectively represented as Ea and Eb. Suppose. Now, when the two atoms are at a large distance from each other, there is no interaction between these actually. So when these two hydrogen atoms are far away, there is no interaction between them. But as these atoms approach each other, when they come close, new attractive and repulsive forces begin to operate between these two atoms. So when two atoms approach each other, then certain attractive forces and repulsive forces begin to operate between them. Let us see what are those attractive and repulsive forces. Attractive forces arise between nucleus of one atom and its own electron. That is, suppose if you say this is one hydrogen atom we have considered. So between the nucleus of this hydrogen atom Na and the electron of this atom Ea, between these two certain attraction occurs because it is nucleus is positively charged, electron is negatively charged. Between these certain attractive force starts created, arised. In the same way, nucleus of one atom and electron of another atom, they will be having certain attraction. So here also this electron of a second atom and it is nucleus of second atom. So between these attraction forces are there. This is one kind. At the same time, the nucleus of one atom and electron of another atom. Between these also certain attractive forces starts, and here between these electron of first atom and the nucleus of second atom, because these are also oppositely charged, hence certain attractive force will be started between these two when two hydrogen atoms approach each other. Okay, similarly repulsive forces arise between the electron of two atoms like Ea and Eb. If you see, this is electron of first atom which is having negative charge, and this is electron of second atom which is also having negative charge. So when these two hydrogen atoms approaching each other, as these two are having same charge, they repel each other. So repulsive force starts between the two electrons of both the atoms. And one more repulsive force is nuclei of atoms. So one more repulsive force starts between nuclei of the both the atoms, because this is a positively charged nucleus, this is also positive charged nucleus. When atoms approach each other, between these also repulsive force started. So in this way, when two atoms approach each other, certain repulsive forces as well as certain attractive forces will be started. They come into force. Okay. Now, attractive forces tend to bring the atoms to close each other, whereas repulsive forces tend to push them apart. Say these are the attractive forces. These attractive forces will tend to keep those atoms together. They will try to bring the atoms close to each other. What are those attractive forces? Attraction between the nuclei and electrons of both the atoms. These will try to bring the two atoms close to each other. Whereas the repulsive forces between the same kind of particles, nuclei of both the atoms and electrons of both the atoms, these will be repelled each other. These repulsive forces will try to keep the atoms away from each other. Experimentally, it has been found that the magnitude of new attractive force is more than that of the new repulsive forces. As a result, the two atoms approach each other and potential energy decreases. Ultimately, a state is reached where the net force of attraction balances the force of repulsion and the system acquires minimum energy. So when these two atoms approach each other at a certain distance, at a stage, these two atoms reach a stage where the net force of attraction balances the net force of repulsion and the system acquires a minimum energy. At this stage, where the minimum energy is created, the two hydrogen atoms are said to be bonded together to form a stable molecule having the bond length around 74 picometers between the two hydrogen atoms. Okay, in that way, a bond is created between the two atoms when they approach a particular distance where the attractive forces will balance the repulsive forces between the system and the system comes into least energetic state. At this state, both the hydrogen atoms will be bonded together. Since the energy gets released when the bond is formed between the two hydrogen atoms, the hydrogen molecule more stable than that of isolated hydrogen atoms. So what's happening when a bond is formed? Energy is released out, which we call as bond length, bond energy. Okay, so as energy is released, the molecule will be with the least energy, and hence we can say it is more stable. Because if energy is least, stability will be more for the system. So when two atoms bonded together, certain amount of energy will be released then, and hence the bonded molecules will be having less energy or more stability. That's why you say the hydrogen molecule is more stable than that of isolated hydrogen atoms. Okay, the energy so released here is called as bond enthalpy or bond energy. Now let us see about orbital overlapping concept. In the formation of hydrogen molecule, there is a minimum energy state when two hydrogen atoms are so near that their atomic orbitals undergo partial interpenetration. Okay, in the formation of hydrogen molecule, what happens? Two hydrogen atoms approach each other. At certain distance, the attractive forces will be balanced with repulsive forces. At that state, both the atoms are said to be in the bonding together. At this stage, atomic orbitals they undergo the interpenetration, the partial interpenetration. This partial merging of atomic orbitals is called overlapping of atomic orbitals, which results in the pairing of electrons. So the hydrogen which is having one electron in its orbital approaches the another hydrogen atom which is having one electron in its orbital. When these two hydrogen atoms approach each other a certain distance, the orbital of one hydrogen merges. That means it interpenetrates into the atomic orbital of another hydrogen. This penetration of orbital of one atom into orbital of another atom, which is a simply merging, is called overlapping of atomic orbitals. By this overlapping of atomic orbitals, the single electrons present in the both the atomic orbitals now they will be paired. So this is called penetration. See, one s orbital partially merging with the s orbital of another atom. This merging of atomic orbitals is called overlapping. See, one s orbital is merging with the p orbital of another atom. This is called merging or overlapping of atomic orbitals. So here also you can see overlapping of atomic orbitals is happening between the two p orbitals of two different atoms. Here, the extent of overlap decides the strength of the covalent bond formed between the atoms. So, if the extent of overlapping is greater, that means merging is if it is greater, then the bond so formed will be stronger covalent bond. If the merging is less, then the interaction or the interpenetration of orbitals if it is less, then the strength of the covalent so formed also will be less. In that way, you can say the extent of overlap decides the strength of a covalent bond. In general, greater the overlap, the stronger is the bond formed between the two atoms. See here, generally we say the SS overlapping is somewhat less in extent than the sp overlapping, which is less than that of PP overlapping. So the bond is stronger in case of PP overlapping. The covalent bond formed by the overlapping of two p orbitals of both the atoms results a strong covalent bond when compared to the remaining two cases. Okay, as the extent of overlapping increases, strength of the covalent bond so formed will be increased. Okay, therefore, according to orbital overlap concept, the formation of a covalent bond between two atoms results by pairing of electrons present in the valence shell having opposite spins. Now let us see overlapping of atomic orbitals, how it is done. A covalent bond is formed between two atoms is formed when the two atoms approach each other closely and one atom overlaps its valence orbital containing unpaired electron with the valence orbital of the other atom that contains the unpaired electron of opposite spin, so that the two electrons will be paired. Now that merging of those two atomic orbitals is called overlapping of atomic orbitals. The so formed electron pair is attracted to the nuclei of the both the atoms. This bonds the two atoms together. See here, individually, both the hydrogen atoms are having single electrons in their s orbitals. When these two hydrogen atoms approach each other, come to a certain closer distance. At the distance, the s orbital of hydrogen containing single electron merges or overlaps with the s orbital of another hydrogen containing single electron, so that the electrons too will be paired, one with the clockwise spin, another with the anti-clockwise spin. Now this pair of electrons are being attracted by both the nuclei. These are held by the attraction of both the nuclei. In this way, this pair of electrons bonds the two atoms together. In that way, a hydrogen molecule is formed. So in the hydrogen molecule formation, there is occurring S-S overlapping. Okay. Now let us summarize the important points from this valence bond theory. The main points of this theory. One among them is a covalent bond is formed by overlapping of atomic orbitals of valence shell of the two atoms. So when two atoms approach each other, the atomic orbitals present in their valence shell, they overlap each other and thus they pair their single electrons, and hence a covalent bond is formed between the two atoms. Next point, only half-filled atomic orbitals, that means orbitals singly occupied, can enter into overlapping process. So overlapping will be done between the atomic orbitals of two atoms, the two which are having a single electron in them. Half-filled atomic orbitals only, they participate in this overlapping process. The resulting bond acquires a pair of electrons with opposite spins. So initially, both the atomic orbitals will be having a single electron with might be the same spin. But when two atoms approach each other, while this overlapping is occurring, those electrons will be paired with one electron clockwise spin, another electron with the anti-clockwise spin. In this way, they make a pair of electrons with opposite spins. These electron pair formed here will be attracted by the nuclei of both the atoms, and hence a bond is created between them, that we say as a covalent bond. Now another point, the atoms with the half-filled atomic orbitals must come close to one another with their axes in proper directions for overlapping. So when two atoms approach each other at a proper distance and in a proper direction, then only the atomic orbitals of these two atoms, which are having single electron in them, they overlap each other and they make their single electrons paired, and thus they form a covalent bond between them. This all will be occurred when those two atoms approach a certain distance. They should come close to one another, then only at a particular distance in the particular proper direction, then only this overlapping occurs, and thus they result in the formation of a covalent bond. Okay. Next point. As a result of overlapping, there is minimum electron density, maximum electron density somewhere between the two atoms. So as overlapping is occurring, the two electrons present in these two orbitals will be paired up, and hence it creates a maximum electron density somewhere between the two atoms. A large part of bonding force comes into existence from the electrostatic attraction between the nuclei and the accumulated electron cloud between them. So in this way, the electron cloud will be having maximum electron density between the two atoms. Now one more point. Greater the overlapping, higher is the strength of the chemical bond. So if two atomic orbitals of two atoms overlap each other to a maximum extent, then the covalent bond formed will be much stronger. So in this way, based upon the extent of overlapping, the strength of the covalent bond formed will be dependent. The amount of energy released per mole during overlapping is termed as bond energy or bond enthalpy. So we know when a bond is formed, the system or the molecule be with the minimum energy, means it releases certain amount of energy out. That amount of energy released while a bond formed is called bond energy or bond enthalpy. Okay, this energy stabilizes the system. Hence, the molecule formed has less energy and consequently more stable than the isolated atoms. So when you compare the isolated atoms, it means individual atoms and the molecule. If we compare those two, atoms or individual atoms or isolated atoms will be having more energy, less stability. Whereas the combined molecules will be having less energy or greater stability. So molecules are more stable than individual or isolated atoms, and energy will be quite opposite way. Okay, for example, if we consider hydrogen single or isolated atom and hydrogen molecule, if we compare between these two, hydrogen atom will be having greater energy and less stability, whereas hydrogen molecule will be with greater stability and less energy, because when two hydrogen atoms approach each other, their atomic orbitals overlap each other and they form a covalent bond. While bonding is formed, certain amount of energy will be released from these two atoms. That energy we call as bond energy. And thus the system formed means the molecule formed will be having less energy than the individual atoms. So it is being more stable than individual atoms. Okay, this is about valence bond theory. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website aimstoday.in for latest updates on recorded videos.